Assalamualaikum and greetings. My name is Muhammad Karim and I'm going to explain the basic introduction and theory about series of parallel pumps. Before we start, we're going to need to know the function of pumps. Generally, the pumps and distributed pumps are used to transfer fluid by conventional rotational kinetic energy to hydrodynamic energy, which is velocity of the fluid flow. However, a single pump cannot produce the head or flow rate for a particular system. So the system can be installed with two or more pumps. However, series and parallel arrangement can produce a different result with one another. In theory, pumps in series produce the twice of the heads, and pumps in parallel produce the twice of the flow rate in the system for a given heads. During the experiment, the head can be calculated by using this energy equation for the pump inlet and outlets. The value of different velocity and elevation are small, so this value are neglected. Power of the fluid motion can be expressed as this formula, and the power of the water horsepower can be calculated as this formula. Thank you, and I'm gonna let's pass to the next presenter.
Okay, hello, my name is Puteri, not Enosofa Wentika Marisham. My metric number is MA19251. So, here I want to present about the method and procedure. Okay, so our introduction is this experiment was carried out in order to achieve the experiment's objective. So, the objective of this experiment is to know about the characteristic of single pump operation with various pressure and flow rate. So below are the methods and procedures involved in conduct this experiment. So our apparatus is centrifugal pumps, motor, water storage tank, hydraulic pump, and manometers. Okay, we have three types of experimental. First one, single pump, series, and parallel. So, the single pump operation is we first thing is we connect to the stop cord as shown in the figure, and then we handle the parallel to the pipe until the valve is closed. We handle perpendicular to the pipe until the valve is open, and then switch on the pump, which is labeled at 9 with the main switch on the switch box labeled 11, while pump 2 must remain off. So set the volumetric flow V with the drain cork labeled to ensure the continuous water flow into the reservoir. After that, we record the measured values, which is the section on the intake at the side of the pump label. Record the delivery side of the pump. After that, we vary the volumetric flow of it and repeat the previous measuring procedure. So this is for the series. The step is same with the single. This we just adjust the switch and record, which is we record the suction 1 on the intake side of pump 1 label. Record the delivery 1 on the delivery side of the pump. After that, record the suction 2 on the intake side of pump 2. After that, record the delivery 2 on the delivery side of pump 2. And then vary the volumetric flow and repeat the previous measuring procedure. And lastly, this is for the parallel. The step is same with the previous one. We just have to record the suction 1 on the intake side of pump. Record the delivery 1 on the delivery side of pump. Record the suction 2. Record the delivery 2 at the side of pump 2. And record the water flow at the label. So that's all. Thank you.
Hi, Assalamualaikum and a very good day. So my name is Muhammad Farhan Hakim bin Razak and my metric number is MA19244. So today I will explain about our results of this experiment. So first, this chapter will provide a brief explanation of the experiment output results. So first thing first, we go for the formula. So for the calculation of net head and water horsepower, we were using these formulas and assumptions. So which is like this one. So volume flow rate and then all of these things. So to get a net head formula, we use this formula where P is the pressure and V for the velocity of water and G is for the normal gravity force and Z is the elevation of pipe and P which is the density of water at 25 Celsius. And then we will calculate about water horsepower by using all these kind of things and then we calculate the area of the pipe. And the assumption of this is water is 25 Celsius constantly during the experiments and Z1 and Z2 is equal to 0 and properties of water at 28 so density is 997 kg slash m cube. So this is the detailed calculation for the single pump configurations. So first we calculate the velocity of the water by using this formula which is V equals to Q divided by area and then this is the results that we got. And then we calculate the pressure difference of the water by using this formula and then we can continue calculation by using this formula for the net head pump and after that we can calculate the water horsepower by using that rho g vh formula and this is the data we got and after that once we got the data the calculations then we can calculate the efficiency of single conversion pump by using this formula. And then this is the efficiency that we got. And next for the series pump configuration, same with the single pump. We used to calculate the velocity of the water first by using same formula, and then this is the velocity we got. And then we calculate the total pressure, which is by using this formula. And then we calculate the net head by using the same formula as before and then calculate the water horsepower also like the same formula and then finally we calculate for the efficiency and then this is the efficiency we got in the data and the last one is the parallel pump configurations. So basically we calculate the velocity first and then we'll determine the lowest total pressure between two pumps to continue our calculation net head of the parallel pump configurations. So this is the outflow flows and then after that obtaining the outflow pressure we can continue calculation for the net head by using this formula and then we find the water horsepower by using the same formula as before and this is the data we got and lastly we calculate for the efficiency of the parallel configuration pumps and then this is the efficiency that we got and next we go for the graph which is this is the graph that we get after for the single pump configurations and then this is for the series pump configurations and the last one is the parallel pump configurations. So I think that's all from me. Thank you so much.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Tuan Muhammad Izzat bin Tuan Muhammad Puzi. My metric number MA19257. I from section 02 and group 6. And now I will explain about 4.3 discussion. For question A, compress the experiment performance curve to its theoretical curve and describes the experiment performance curve for single, series, and parallel shows the same relationship between flow rate and pump head. The pump head are inversely proportional to the volume flow rate. In series pump configuration had the highest pump head compared to other pumps. The pump will be difficult to operate due to the extremely flat pump head curve. The head in series pump configuration is larger by inserting two single heads at the same time. The parallel pump configuration has the highest flow rate compared to series pump. For the theoretical curve, it designed the flow on the x-axis horizontal and head pressure on the y-axis vertical. The curve begins at the point of zero flow and gradually descends until it reaches the pump run-out point or maximum flow rate. For question B, from the results obtained, state the use of series and parallel pump. For series, Pumps are used in series in a system where substantial heat change takes place without any appreciable difference in discharge. When two or more pumps are arranged in serial, their resulting pump performance curve is obtained by adding heads at the same flow rate. For the parallel pumps are useful for systems with considerable discharge variations and with no appreciable heat change. When two or more pumps are arranged in parallel, their resulting performance curve is obtained by adding the pump's flow rate at the same head. For the last question, explain why the system with series pump configuration would generate higher pressure than the parallel pump configuration. A system with series pump configuration would generate higher pressure than the parallel pump configuration because when centrifugal pumps are connected in a line, heat increases from one pump to the next. In operation, single-stage pumps in series are seldom encountered. More often, multi-stage centrifugal pumps are used. When two of the same pumps are in series, the combined performance curve will have double the head of a single pump for the given flow rate. In conclusion, we can conclude that our experiment was successful. In this experiment, we have learned about how to design a complete measurement technique for fluid flow. The measurement was taken by using visual instrumentation that was DAISY-lab. The visual instrumentation modeling is used to get more accurate value using strain and flow sensors. For this experiment, we can see a performance curve that shows how the net head decreases as the volume flow rate increase. As the result of arrangement in single pump, parallel pump and series configuration, the capacity of the pumps was statistically SH. The volume of flow rate is approximately identical to that of a single pump when it is linked in series, but the net head increases. When many pumps are linked in series, the net head rises with the volumetric flow rate.